A warm greetings to everyone. I am G. Pavitra from 2nd MSc Mathematics. I am doing my project under the guidance of Dr. M. Anthony Arogyasamy, Assistant Professor, Department of Mathematics. My project was titled as Quinture Crypto System. Preliminaries. Graph. A graph is a collection of vertices and edges. For example, a social network can be represented as a graph. People it's equal to vertices. Friend connection is equal to edges. Hamiltonian tour. A Hamiltonian tour is a cycle in graph that visits every vertex exactly once and returns back to the starting vertex. Cryptography. It is a process in which the plain text is converted into some code language so that the message becomes unreadable for any unauthorized person. The code language is usually referred as ciphertext. This process is further termed as encryption. Cryptanalysis. It is the process of returning back the secret message from the coded language. This process is further termed decryption. Cryptosystem. Cryptosystem is the combination of both encryption and decryption. Cryptography plus cryptanalysis is equal to cryptosystem. Chaining operation. A chaining operation is a technique in block cipher modes where the output of one block is linked to the next block so that each block's encryption depends on the previous block's result. Quinture. A quinture is a sequence of legal queen moves that visits every square on the chessboard exactly once. Algorithm for the quinture crypto system. Encryption algorithm. The following are the steps of the encryption algorithm. Step 1. Replace every character in the plain text message with its corresponding location in the key, and the result will be 2n characters for the each position. Step 2. Label every character including n1, n2. Space is not necessary. Execute the function h of ni is equal to ni plus I mod r if I mod r not equal to 0. Ni plus r if I mod r equal to 0. Here r is the operation key. Step 3. Substitute each h of I 1 to r plus 9. It is corresponding English alphabets. For example, 1 represents A, 2 represents B, so on. The plain text we have obtained is encoded in the ciphertext. Step 4. Match two alphabets together consequently and locate the shortest route for each pair by make use the secret keyboard and quinture. Now the graphs that have been acquired are referred as cipher graphs. Special case, if the pair has the alphabet as say AA, consider it as root A and find the graph. Step number 5. At last, merge the cipher graphs by using mergers. Here merges are diagonal edges with unrestricted length. The merged graph is the message to be sent to receiver. Note, the sender should be aware of hiding the operation key in the merged graph. Decryption algorithm. The decryption system uses a two-way method. Since we take the shortest path for each cipher graph, every graph gives two possible results when decrypting. Even thought both options are checked, the correct message is found only through trial and error. The steps for decrypting are given below. Step 1. Start by separating the encoded graph into cipher graphs by eliminating all merges. Using the quinture and the key, find the alphabet combinations for each cipher graph. Each graph will produce two possible alphabet pairs. Convert each alphabet to its numerical value. A equal to 1, B equal to 2. Now apply the inverse function. H of ni inverse is equal to ni minus I mod r if I mod r not equal to 0. Ni minus r if I mod r equal to 0. Here r is the operation key. Step 4. Verify each integer pair as follows. Discard the pair if any value is negative. Reject the pair if any value exceeds mn. A pair is valid only when both integers lies in the range 0, 1 and mn. Use the number pair to look up the spot on secret keyboard and put the element from that spot. First, we shall choose the three required keys before encrypting the messages. Consider the chessboard. We chosen the keys from a 8x8 board. It is a 8x8 Hamiltonian grid. Figure 2 represents a secret key. Here the empty space represents the blank. Key 1 and key 2 must be exchanged between the sender and receiver. Suppose that the sender has chosen the operation key R equal to 7, that is key 3 equal to 7. The plain text to be encrypted is escape. Encryption. Locating the plain text. Step 2, chaining operation with R equal to 7. Step 3, converting into cipher text. Step 4, converting cipher text to cipher graph. Step 5, merging the cipher graphs. Step 5 is a cipher graph of escape. Decryption. Step 1, split into cipher graphs and find the combination of cipher text from the keys. Step 2, convert the cipher text alphabets into numericals. It Step 2 has two cases, case 1 and case 2. Step 3, inverse chaining operation. It is also have two cases. Step 4, check for the variability in each case by pairing the values of the inverse of the inverse chaining operation. Values are greater than 64 are neglected. Values containing negative terms are neglected. Replace the values by the key element from the keyboard. It is a trial and error process. Since the first possibility looks more appropriate in the sense of meaning, I would conclude that plain text is escape. Applications. In this chapter, we give some applications used in various fields like military, online banking and financial transports, secure communications, etc. Use of crypto systems for secure communication. Interaction secure communication is the primary use of crypto system using networks or the internet to transport data between people helps to protect it. The original message is changed into secret coded version by the crypto system via encryption before being sent. The confidential transmission cannot be decoded by hackers or unauthorized users. When the communication reaches the recipient, it is converted back into the original format using a decryption key. Secure communication is used in mobiles, messaging apps, secure websites, video calls, and emails. It is ensured that the communication is private, unmodified in transit, and only received by the intended recipient. These are my references. Thank you.